Hello children, welcome to the virtual session again. So today we are going to continue with the journal writing as you need sufficient time to complete your journal, and today you are going to uh, watch two videos on the title which we have already done, on the experiments which we have already done, effect of yeast on dough and carbon dioxide balloon. So this experiment you are going to watch in the video how it is being performed. Since you are writing in the journal, you will get some experience of how to do that experiment, and once we also will try in school, we will do this experiment in the school. Now you just watch the video and you get an experience of how this experiment is done. I hope you all have completed your journal or you all are writing your journal. This experiment video will help you to understand the experiments clearly. So please do watch the video, children. Have a great day.
In this experiment, we're going to look at life in action and investigate some of the ingredients that make life work. Now, most organisms need air to breathe and some kind of energy source to live. And by energy, we usually mean food. But in order to thrive and multiply, conditions need to be just right. And that's what we're going to investigate. We're going to use a very simple form of life. This is baker's yeast. And it's alive. It's a tiny single-celled kind of a fungus. And given food and air, it will grow and multiply. But we're going to see which kind of conditions it likes best. And to do that, I'm going to make up a series of sugar solutions. Before you start, print off the glass diagram from your study journal so that you can record which sugar solution is which. I've got 4 glasses, each with a spoonful of sugar in, and I'm going to add the same amount of water to each. So this first one, I'm going to add cold water. And in the next one, I'm going to put in the same amount of just boiled water from the kettle, but be careful you don't crack the glass. And in the final 2, I'm going to put the same amount of water that's at body temperature or blood temperature. So I've just tested that with my finger. Now, give them a quick stir. Cold water. Boiling water. Blood warm. And blood warm. So now I'm going to add a sachet of yeast to each glass. And then I'm going to mark off the level of the water on the side of the glass. Now, this last glass I'm going to cover with cling film to restrict the amount of air that the yeast has to work with. So set your experiment up in the same way so that we can compare results. I'm going to give this 5 minutes and see if anything's happened. Well, that's 5 minutes up and the yeast has clearly sprung into action because it's started to produce a foam. Now, this foam is the result of the yeast using the oxygen in the air to digest the sugar, and it's producing a gas, as a waste or byproduct. In this particular case, it's carbon dioxide. And that's the process that makes bread rise in the same way as it's doming and making the cling film rise here. Now, to monitor the experiment and keep track of the process, I'm going to measure the thickness of the foam and record how it changes over time. So this one is 2 centimetres thick after 5 minutes, and this one is 2 centimetres thick. Okay, so I'll give that another 5 minutes and then I'll come back and make another measurement. Okay, well that's 10 minutes up, and this one, which was the boiling water, doesn't seem to be doing very much at all, and this one, which was the cold water, appears to be just starting to produce a very thin layer of foam. And these two are still doing really well, producing more foam. Just going to measure the thickness again. And this foam has gone up to 6 centimetres. This one's 5 centimetres. Now, to find out what these observations mean and to interpret the results, you'll need to join in with the online discussion.
Today on Sci Guys, fermenting yeast and sugar. Welcome to Sci Guys, I'm Ryan.
And I'm Teresa, and today we're looking at fermentation with sugar and yeast.
We'll be producing gas, and it won't be me this time. This is a viewer-requested episode. Thank you to this viewer for recommending this episode.
Fermentation is a chemical breakdown of substances by bacteria, yeast, or other microorganisms, usually involving the production of gases and heat.
The equipment and ingredients you're going to need for this episode includes multiple bottles, they can be glass or plastic,
Sugar,
yeast,
balloons,
a funnel,
measuring utensils.
and warm water.
We're not working with anything hazardous in this episode, but we still recommend gloves, goggles, and an apron or lab coat to protect from spills and splashes.
The first step in our experiment is to add all your ingredients into the bottles. Using a funnel, add 1 package or 2 1/4 teaspoons of yeast. Now we're going to add the sugar. In the first bottle, we're not going to add any sugar. In the second bottle, we're going to add 1 teaspoon. In the third bottle, 2 teaspoons. And in the fourth bottle, 3 teaspoons. With all your dry ingredients in the bottles, add 1 cup of warm water into each bottle. With all the ingredients in your bottle, cover your bottle with your thumb or put the lid back on and give it a gentle mix.
With all the ingredients in the bottle, put 1 balloon on each bottle spout and leave them somewhere warm to sit for an hour.
Over the next hour or two, the balloons will gradually grow in size. After a few hours, you'll notice the balloon that was covering the bottle that had the most sugar in it grew to a larger size. Let's look at this experiment a little closer. Yeast is a fungus, and there are about 160 known species of yeast. Yeast is very small. 1 gram holds around 25 million cells and has been used for thousands of years to help bread rise. But how does a fungus help bread rise? It has to do with what yeast eats, how they metabolize that food, and what waste products are released. Yeast feeds on sugars and starches. When the yeast consumes the sugar in our bottle, it breaks it down to be used as energy. But like all living beings, waste products are produced when metabolizing food. When the yeast metabolizes the sugar, the waste produced is carbon dioxide gas and ethanol. The carbon dioxide gas floats out of the liquid into the bottle, producing bubbles, and eventually floating up into the balloon. As the yeast consumes more sugar and produces more carbon dioxide, the pressure inside the bottle and balloon increases. This pressure presses on the walls of the balloon, causing it to expand and grow. The equation for this reaction looks like this. The reactant sugar, sucrose, is on the left, and the products, ethanol and carbon dioxide, are on the right. The bottles with greater amounts of sugar have more food for the yeast to consume, which results in larger amounts of carbon dioxide produced and a larger balloon on the top of the bottle.
That's it for fermentation. Thanks for watching.